Good morning, everybody, and welcome to our next installment here on our journey with Prisma Access. Today, we're going to be talking about improving your network security using Prisma Access for IoT and DLP protections. A couple of add-ons that we have here for Prisma Access. Now, this is going to help you protect your entire platform through Prisma Access, Prisma SaaS, all of our different pieces of our platform. But we're going to be concentrating on this from the Prisma Access point of view. For each of these, we're going to be talking a little bit about what this protection is. What is IoT security? What is DLP? We'll talk a little bit about the components and the flow and the idea of IoT security architecture and integration, also DLP components and DLP integration with Prisma Access. There will be a Q&A section at the end. So if you have questions, there is a Q&A button, and we'll save the questions till the end of the sections after my presentation, and we'll come back and we'll answer any questions you might have. So let's get into this a little bit. First of all, why do you need IoT security? Well, the Internet of Things are usually unmanaged devices that are out there. And all of the time, you can look at news articles and read the news and hear about new threats and things like that in headlines. There was a few years ago, the first of these really big IoT threats was thermostats, internet connected thermostats that launched an attack against a huge core DNS server that took down a significant portion of the internet. And it was a DOS attack from thermostats connected to the internet. So this whole Internet of Things is usually a bunch of devices that are not managed. There aren't signatures written for these things. There's no real way to easily see what sort of communication is going on. And more and more and more of these different vulnerabilities and attacks, things like that for IoT devices are out there. The existing solutions just don't work very well. First of all, there's no real visibility into your IoT connected devices for any real degree. Most security solutions use signature-based protections. They use signatures to identify devices, and they simply can't scale to the number of new devices that are out there all the time and the new devices that are being launched all the time. There's also the fact that they're very difficult to implement. You know, it's really difficult when you have to have changes in your network, or you have to have different probes and different sensors deployed in your network to identify these devices. And even given that, the existing solutions really give you visibility into devices and maybe behavior of devices, but no real protection. So you think of them more as devices that or things that will show you indicators of compromise, or intrusion detection devices, not protection devices. So really, if you can't see it, you can't stop it. And on top of that, if it's very difficult to implement and requires changes to network architectures and things like that, it just becomes really hard to do. What we really need and what we offer with our IoT protection with Prisma Access and throughout our security platform is the ability to give you comprehensive device visibility, to understand what's out there. When you think about it, at home, how many internet connected devices do you have? How many things like your Google Assistant or Alexa or your doorbells or your thermostats or your TVs, your refrigerators that are all connected to the internet that don't have any built-in security things, or you may not even realize what they're doing, what sort of chatter they have, what sort of traffic, what sort of behaviors, who they're checking in with, where they're checking in, what sort of information is being uploaded or downloaded. So first thing you have to do is understand what devices are out there. Next is to assess the risks of these internet connected devices, because not every device is going to pose the same sort of risk, nor even the same device pose the same sort of risk to different organizations. So we have to understand how that works. We also not only do that, but you need some sort of positive risk reduction policies. You need something that's going to be automated and not manual. And this is what we offer you, both to prevent known threats and to detect and respond to unknown threats. And that's really what we can do here with our IoT protection, is automate that entire life cycle. Also, in a enterprise deployment, an enterprise environment, the other complication is many of these IoT devices don't necessarily belong to the IT team. They belong to other teams. You have unmanaged devices. You may even have personal devices, as well as normal things like your card swipers and your security cameras and things like that that could be part of the security team and not necessarily the IoT team. So the fact that this sort of crosses over to multiple different teams in a large environment also creates this other issue that, again, with automation can make this much easier. So over the next few slides, we'll take a look at all this. We'll talk about understanding the assets, assessing the risks, using our policy-based protections to reduce risk, preventing known threats and unknown threats. So the first thing we have to do is understand what's out there to identify these devices. We do this with a combination of machine learning and app ID. We're able to discover most of the IoT devices in your network within a couple of days. Some things just don't connect that often or aren't connected all the time. Well, therefore, we're talking about 90+% of devices. Things that are constantly connected, yes, we're going to find very quickly. But if you had, say, for instance, in a hospital environment where you have IV drip devices, IV drip machines that may not be in use all the time, you know, you bring it out, you attach it to a patient, the patient leaves, it goes back into storage, comes back out a week later. There's going to be things like that you have to think about. We're going to continuously monitor these devices to make sure that we don't miss anything that's out there, whether it's occasionally connected or always connected. And we have the ability, of course, to detect these never before seen devices. We can collect these attributes. We have 50 or more behaviors or components, attributes that we look at to understand what the assets are, what it is that's out there. That second piece was assessing risks, right? So we have our real-time monitoring and risk scoring that's going to allow you to view and understand what sort of risks are out there. Track changes in device behavior. Also do retrospective analysis to be able to understand how behavior is changing over time. We do other things too. We look at vendor advisories and vulnerability information from all kinds of different feeds, things like that. And we're able to give you risk levels that can even be customized for your environment so you can understand the risk levels of these different devices and device types that are in your network. Additionally, we're going to give you risk reduction policies. We're going to give you policy recommendations to be able to allow normal behavior of these different devices. Once we've understood what these devices are and how they behave and what is normal, we have the ability to integrate security policy rules and security profiles to be able to offer policy recommendations that can either be manually or automatically added into your security policy and your security profiles. We have our proven technologies to be able to protect you from malware, spyware, exploits, URL filtering, all those sort of things, using DNS for command and control, all of those sort of things to help prevent known threats, as well as the ability to detect and respond to unknown threats using a combination of machine learning and also our traditional unknown threat detection, threat cloud, and things like that, to be able to block unknown file and web-based threats. The ability to look at deviations in real-time behavior and be able to add context to that and respond to these changes. We partner with other devices in the platform, other pieces and parts of Palo Alto networks such as XSOAR to automate incident responses and detections and remediations and do all those sort of things. And of course, we share the information across all of the pieces and parts of our platform. How does this work with Prisma Access? Well, let's take a look. First of all, Prisma Access, and of course, other devices within our platform, your firewalls and Prisma SaaS and all those sort of things, are going to be able to see these devices on the network, primarily through DHCP requests and connections, either going through or request for devices to connect. This information is fed to Cortex Data Lake and helps us feed a library or updates of devices. We can then identify these different patterns and different behaviors and different devices. The security processing nodes are going to collect this data that we get from these IoT devices generate what we call EALs, or enhanced application logs, that are going to be forwarded up to Cortex Data Lake. The IoT security solution is going to use machine learning, and it's going to use artificial intelligence and things like that to be able to give you context-aware security suggestions, and also help you understand your inventory and where everything is and what everything is, and catalog for you all of the devices, detect unusual behavior and things like that. We have our security alerts, we have our security policy rules, we have our traffic logs, our threat logs, and things like that. Within Prisma Access, we can use Panorama to gather these suggestions for security policy rules and protections, and be able to push those back up to the security processing nodes in Prisma Access. Of course, other devices and other pieces of our platform are going to also be enhanced with this IoT protections. So we take all the inputs we get, our EALs, our enhanced application logs, our traffic logs, information we get from app ID, DNS traffic, threat logs, all those sort of things are inputs that are going to help us understand device types. You know, is this a security camera? Is this a card reader? What is this? To understand the vendor and the model. Now, not only is this a security camera, it's from security camera company A, and it's model XYZ, and be able to, of course, understand the individual devices, the different instances that are there. To be able to take things like MAC addresses and IP addresses, HTTP information, headers and payloads, and understand what these devices are, identify these devices using all these different attributes, establishes behavioral baselines, and look for anomalies in that, and give you automatic policy recommendations to protect these devices. Once we're able to catalog these, understand what sort of devices exactly that they are, how many there are, where they're deployed, what security zones they're in, all of those sort of things, we now have the ability to give these automated policy recommendations. And we can do this with never before seen devices. So as new devices are added, this whole process just continues along. There's a lot of parameters in the metadata in these enhanced application logs, these EALs, that we are looking at. More than 200 different parameters. So we can match different traffic patterns and different of devices with older traffic patterns, and again, look back in time and understand changes. And we can give you different confidence levels of the information we're getting there. Some of the metadata that we do collect includes a lot of DHCP options, including option 55 parameters, HTTP headers, user agent IDs, protocol headers, things like that. In fact, I have here a picture of a DHCP request and a DHCP reply. And we're able to see those option 55 parameters that we were just talking about, and some examples as to what some of those things are there. In other words, vendor specific information, domain searches, proxies, anything like that that may be used to help us identify the devices. Other DHCP options like vendor class identifiers and things like that are going to help us also. And of course, MAC addresses and which MAC addresses are assigned to different vendors. All those sort of things are going to help us understand what devices are out there. How do you integrate this stuff? How do I get this working with Prisma Access? It's a subscription. It's an add-on. You'll have the licensing for that. And the other piece is just enabling logging to Cortex Data Lake and making sure that we enable the enhanced application logging, the EALs. Now, as you know, in order to forward logs to Cortex Data Lake, traffic has to hit a security policy rule. So we'll either need security policy rules for traffic that's going between zones, looking for DHCP. So DHCP and DHCP relays and probes. So usually you'll need applications such as DHCP for our app IDs ping for the probes. Often, if devices are in the same zone, security zone as the DHCP servers that they might be reaching out to, we may also need to enable logging on the intrazone default security policy rule. That security policy rule that covers traffic that stays within a single zone. So a combination of explicit security policy rules and also enabling logging on the intrazone default are going to be needed, one or the other or both. We'll need to forward these logs, of course, to Cortex Data Lake. So these security policy rules are going to need a log forwarding profile, which in Panorama, this is a Panorama managed Prisma Access, or even the cloud controller base, you're going to need a log forwarding profile. You would do this under the Objects tab, even in Panorama. Create your log forwarding profiles, forward all the logs up to Cortex Data Lake, and of course, make sure you have the EALs, the enhanced application logging, going there. The more information you feed to Cortex Data Lake, the more you feed to the IoT libraries and engines, the better protection we're going to be able to give you. The IoT security app, the cloud-based security app, integrates with PanOS through, when it comes to Prisma Access, through Panorama. In the cloud, we'll have our device dictionaries. We'll be able to give you IP to device mappings and give you lists of these individual devices and device groups and things like that. So being able to identify these devices. And then, of course, give you these policy recommendations. The service dictionary, it's an XML file that IoT security generates and can be imported into your security processing nodes, into your on-prem firewalls, things like that. It's going to give you a list of devices and device attributes that you can use when creating security policy rules. The IP address to device mappings, of course, are going to help you identify individual instances of these different devices. And the policy recommendations are going to allow you to attach these to different device types, different individual devices, different groups of devices, all of those sort of things. The device dictionary is going to give you things such as vendor types, models, operating system families, things like that. Helping to understand what is there. The IP address to device mappings are, of course, going to give you IPs to MAC addresses, host names, device types and categories, vendors and models, and those risk scores and levels that are provided by IoT security to help you identify different groups and devices and individual devices. Based upon this information, these device mappings and our device dictionaries, we're then able to give you policy recommendations and say, hey, this is normal behavior that can be allowed. These are threats. These are things we want to block. We can import these IoT security policy rules and recommendations either automatically or manually onto the security processing nodes for Prisma Access. So what this does for us is lets us leverage our existing deployment of Palo Alto networks, Prisma Access, firewalls, etc., to act as security devices, as well as probes to be able to find these devices and be able to report these to IoT. DLP is the other piece I wanted to talk about today. So why do you need data leakage protection? Well, when you think about it, things have changed over the years. Your data is no longer sitting in a data center on a server behind a security perimeter. Data doesn't really have any boundaries. It's accessed from everywhere. Inside the security perimeter, outside the security perimeter, from corporate devices, from individual devices. People accessing and storing information on sanctioned SaaS applications, Office 365, Salesforce, that sort of thing. Unsanctioned SaaS applications, corporate Gmail versus private Gmail. Things are now, and information is now stored in the public cloud on Azure and AWS and Google Cloud and all those sort of things. You have to think about a lot of things that you've never thought about before with data security. Data sharing models, sensitivity of data, personally identifiable data, intellectual property, all those sort of things. And of course, all of this is harder to track now than it used to be when everything was just behind a perimeter inside the data center. We all know that data breaches are on the rise. I read about them all the time. You can't go a week without hearing a new one. Organizations have lots of sensitive data that they have to protect. PII, personally identifiable information about employees and customers, and things like that, credit card information. There's lots of regulatory and compliance rules for GDPR, for PCI compliance, for payment card, HIPAA for health insurance, lots of things like that. And now compliance is even harder and more difficult and more challenging, mainly because of the human factor. People sharing information incorrectly, security settings for SaaS applications, or data stored in G Drive or Box or things like that with poorly constructed security sharing rules and things like that, whether it's well-meaning insiders or maliciously stealing and sharing this information from insiders and, of course, outsiders. But a lot of times, these data leaks are from unsuspecting insiders that just don't understand what's going on. So protecting sensitive data has a lot more complications than it once did. And when you're trying to come up with a solution to protect your data, well, first thing you got to figure out is, where is this sensitive data? Where does it live? And chances are that answer is not what it was 5 years ago or 10 years ago, or maybe even not a year ago or 2 years ago before the pandemic. Sometimes it's on-premise devices. Sometimes it's on individual devices. Sometimes it's on servers or desktops. But now it could be in cloud repositories. It could exist in sanctioned apps or unsanctioned apps, in email, Slack, file sharing applications, all these sort of things that weren't widely used or around that often a few years ago. Well, once you figure out where that data is, next thing you got to understand is, how's it being used? Who's using it? Are they using it correctly? Trying to figure out where this sensitive data is being shared. Is this data being transferred? Is it in motion? Or is it data at rest, sitting on in the cloud, on somebody's Google Drive or OneDrive or whatever the case may be? Who's using it? Within and without the enterprise and the company. And you really have to know those two things before you can even begin to think about how you're going to protect this. So how are you going to protect this data that's no longer inside a security perimeter? How do you protect data on unsanctioned SaaS applications? I mean, even sanctioned applications, how do you do it? But how do you do it for unsanctioned ones? You know, do you block this information? Are you going to quarantine this information, delete files, all that sort of stuff? Those are the decisions you have to make. But before you can understand how to protect it, you got to know where it is and who's using it. Which is why legacy DLP solutions have become overly complex. Using multiple vendors and multiple servers and databases, agents, services, proxies. Many of them use proxies, all kinds of different stuff. You gotta deploy all these sort of things, and they're like a fragmented deployment. Tons of different points to configure, lots of upgrade. So you end up with lots of siloed environments. You know, a solution for CASB, a solution for your network-based DLP, a different one for your endpoint-based DLP. And all of them can be different. And of course, lots of different vendors, lots of different licensing, lots of different probes, different proxies, different databases. Not only is it difficult and complex, but expensive. Lots of on-premise infrastructure, lots of licensing. Dedicated teams. Because of the complexity, you're going to need specialists to be able to do this. So it becomes resource intensive. There's usually a lot of alerting and alarms and things like that. Lots of manual tuning to be able to get this stuff to the correct levels of sensitivity. Somebody's got to comb through all these alerts. Your SOC team, your NetOps team, both teams. Who's going to take care of this? it becomes resource intensive as well as expensive. Where do you store all these logs? How long do you store them? All those sort of things you have to think about. Well, our solution, our enterprise DLP, is going to give you a comprehensive coverage. It's going to protect data that's in the cloud, on premise, in your SaaS and applications, your IaaS applications, web transmissions, all of the different ideas of data at rest and data in motion. We're going to be able to understand and locate where this data is across the clouds and on your network endpoints, network servers, and all that sort of stuff. Allow you to monitor and understand where this data is and how it's being used, and leverage our DLP engine that is integrated with all the different products within our network security model, and protect and stop this sensitive data leakage. Automatically discovering sensitive data wherever it is, whether it's at rest, whether it's in motion, lets you monitor the use of this sensitive information, understanding who is accessing it, and answering those questions: who, what, when, where, why. Giving you protective actions, stop sharing this, quarantine this, delete this, log this, all of those different things that are available. This all begins with our DLP cloud service. So our DLP cloud service, it's cloud delivered, and it's going to give you an enterprise DLP or data loss prevention solution that's going to help us discover and monitor and protect this data across the network, integrating into all of our different pieces of our platform. Of course, Prisma Access is our focus today, but also all the other pieces of our platform, cloud and physical devices. So there's a single DLP engine that's used for everything. You just configure it one time. It auto syncs. It uses AI and machine learning, has advanced workflows and analytics and all that sort of stuff. But it's a single point at which all of this is done, instead of 100 different or 10 different vendors and 10 different solutions for 10 different pieces and parts. You don't need a proxy solution as well as that's from one vendor, endpoint solution from another vendor. All these pieces and parts that don't integrate, well, within our platform, all of ours is going to integrate. We offer DLP both within our next generation firewalls, physical and virtual machine ones, and of course in the cloud. In our case, with Prisma Access, we're going to have options that help you protect both data in motion, like we would see with Prisma Access or our firewalls, when we see data crossing through that security processing node, that firewall, but also data at rest with our Prisma SaaS and Prisma Cloud deployments. The idea with Prisma Access is, as users and devices are trying to access information through Prisma Access in, say, their SaaS solutions or out on the web or whatever you have. This information is fed to our DLP service in the cloud. Verdicts are rendered, classified, protections are enabled, and all of this is done without any additional deployments or updates or probes or ICAPs or proxies or any of that sort of thing. It's entirely cloud-based. There's no ICAP connections. There's no on-prem DLP solutions needed. No need to connect through proxies or any of those things that you would traditionally have to do. So it's going to make this much easier to deploy. It's also going to be much more familiar to folks that are already familiar with Prisma Access and our security policy rules and our security profiles and the idea of Pan OS. It's going to be much more comfortable. This is going to give us the ability to understand what information we're looking at, what sensitive information it is. You know, is it IP, intellectual property, PII, personally identifiable information, credit card information, social security numbers, things like that. And who is accessing it, what they're accessing it for, where they are, where the information is, and be able to respond to this with different actions to notify or unshare information or quarantine information, prevent access to information. Doing this within different contexts. You know, who are we notifying? Users or managers or the security team? When we prevent access to information, who are we notifying again? So understanding the content and context in the detection part of things and the response part is what we're after here. DLP integration with Prisma Access is very simple. It's a matter within Prisma Access, but in Panorama in any case. We go into the Panorama tab, we get our cloud services configuration, where we do all of our configuration for Prisma Access. It's a matter of activating Enterprise DLP. You can request a trial to check it out. And of course, you can license it and subscribe to it. Understand that if you do this, any sort of profiles for existing data filtering, file upload and download protections, data filtering that we do within Pan OS is going to be deleted and replaced with the DLP. At that point, now your security processing nodes can see traffic coming in, can see users trying to reach all this different sensitive information, files, and can be streamed to DLP for inspection. Verdicts can be rendered to see not only traditional exploits and things like that, but in this case, DLP information. Sensitive information, what sort of information it is, render a verdict as to how we should treat this information, and be able to deploy this out to all of the different pieces and parts of our platform, in this case, Prisma Access, to be able to give live responses to whether we want to alert or block users from reaching this information, whether we need to go in and change sharing settings and things like that, which can be done with our security platform. And of course, blocking known and unknown threats and exploits and things like that could be living in files and things like that on Box and Google Cloud and all that sort of stuff, to be able to give you the traditional PAN-OS protections on top of the DLP solution. So it really helps enhance your security posture here. And then Prisma Access. There's about 850 predefined patterns that can be used in 17 different security profile types. We have actions to alert or block file uploads and downloads, supported through all of our web browsing based apps, which is a large number of our app IDs. And there's even 11 specific apps just for Prisma Access. We can support file upload and download and blocking and alerting for 22 different file types. We have our machine learning, ability to assign different confidence levels to be able to create custom data patterns. As you can see with some of our other pieces and parts of our security platform, we offer differing levels of actions and control points and things like that. With our SaaS security to be able to quarantine files, delete shares, do things like that. So different actions, different numbers of supported apps, different numbers of supported files, things like that for different pieces and parts of our platform. But of course, today we're talking about Prisma Access. So hopefully this helps you understand some of these add-ons and where they're going to be able to help you to increase your response and to secure both your IoT devices and your sensitive data, wherever it might be, and whoever may be accessing it, using whatever devices they're accessing it with and wherever it's being stored. And this is, of course, going to help us protect your digital way of life. So at this point, we'll open the floor for any sort of questions you may have.